All right, welcome everyone. I just wanted to quickly cover some of the details in today's lesson as I'm away. So I just wanted to make sure that everybody's kind of on the same page as we move into this activity, because these ray diagrams are going to be quite important for us moving forward in the unit. So just a quick little refresher off of our last lesson on some of kind of the key terms that we talked about. First one that we're going to see is the light that is coming into the mirror itself. First off, just to quickly show you here, oftentimes you're going to see mirrors kind of shown like this with one smooth side and one side where there's kind of dashed lines. So really all this is showing us that the reflective side here is the smooth side, and then the dashed lines are just showing that is the back side of the mirror. So when we have a mirror, we are going to have light coming into that mirror. Again, that is going to be coming in this direction here, right? This is going to be coming in that direction, and that is what we are going to call our incident ray. And then we are going to have our reflected ray then coming out of the mirror itself. But in order to figure out what the reflected ray is going to be coming out at, we first need to figure out our normal. So remembering again that our normal is a perfectly perpendicular line to that mirror itself. So you'll just take your protractor here. There'll be protractors for you in class today. You'll line it up where the point here is directly on the location where the incident ray is contacting the mirror itself. And then you'll just kind of dash a little line at 90 degrees. Okay, so once we go there, we can pull that off. We can take our ruler and we can make a line going from the point at which the incident ray contacts the mirror and run that straight through our other line that we have made. That is just guaranteeing that that line there is exactly 90 degrees from the mirror itself. Now, we do know that based off of our last gizmo that we completed is that the angle of incidence is going to be equal to the angle of reflection. Therefore, we can actually measure right here, which is our angle of incidence, in order to figure out where we need to draw our angle of reflection. So in order to do that, again, you will just take your protractor, right? You are going to take the point of your protractor, which is right in the middle, right? You will run it so that the line on the bottom of your protractor is lined up with the normal, and then you will measure the degree or the angle that incident ray is coming off of. So we can see here, right, I have the 30 degree mark, so that will be approximately 31 degrees. So looking at that, if my incident ray is coming in at 31 degrees to the normal, or my angle of incident, then I know that my angle of reflection must be equal to that. So then I can just simply take my protractor, flip it upside down, again running my 0 degree line right along my normal, and I will see that at 32 degrees, I will quickly just make a little mark, right? Be careful in this area. A lot of the times what I will see students do is instead of moving 30, 31, 32, they will get to that 30 mark, and because now the protractor is upside down, they're going to go 30, 31, 32, and that is not correct, right? Instead, you want to make sure that it is 32 away from 0. Okay, so then using that, again, I go to my point of intersection with the mirror. I'm going to take my pen, put it there, and I'm going to run my angle of reflection, or sorry, my reflected ray away from that mirror itself. Oftentimes you'll see that we put a little arrow on there just to keep ourselves correct. Now, knowing that, right, the angle of incidence equals the angle of reflection, so I will see that that will also be 31 degrees. Okay, so those are exactly equal to each other. Remember that this here, the perpendicular line, is what we call our normal. This here is my reflected ray. And this here in the middle is my angle of reflection. Always, if you aren't 100% sure if you have done the question right, it's always a nice thing to be able to go back, use your protractor, measure the angle of incidence and the angle of reflection to make sure that those are exactly equal to one another. If they're off by 4 or 5 degrees, you have probably done something wrong and you should go back to double check your answers. Okay. So what we're going to be getting into now is drawing ray diagrams to help us determine where an object will be located if we are looking at it in a specific mirror. Now we are just going to be looking with plain mirrors right now, which are just simply a flat mirror, no curves or anything to make it a little bit more difficult. So at this point in time, there are a few steps that we need to take. The first step that we need to take is we need to determine where that object will be. Now, when I look at a mirror, you will notice that if you take any mirrors yourself, if you take that object and you move it closer to the mirror, if you look in the mirror itself, it's going to appear that that object is very close to the mirror as well. However, when you move that object away from the mirror, you will notice that looking into the mirror, it appears that that object is moving further into the mirror. Now, with that being said, this makes it pretty simple for us because we do know that the distance from the object to the mirror is going to be equivalent from the distance from the mirror into the back of the mirror itself or into the virtual plane of the mirror. So again, in order to do this to be a little bit more correct, we need to make sure that we're using a protractor in order to figure out what is exactly perpendicular to the mirror itself. So here I'm going to take my protractor and try and make sure it is as close as possible. I'm going to put it once again along my mirror. This is just to make sure that I have the closest distance from the mirror itself to my object, which in this case is just one simple point. Right here, I'm just going to put a little dot over here. That is just going to show me that when I am using my ruler, it is going to be traveling perfectly perpendicular from the location of the object to the mirror itself. Because if I were to take my ruler and measure, let's say, from the object itself down in this direction, and let's say it comes out to be 2 3/4 inches, right? If I were to measure it actually perpendicular, it would only be about 2 1/4 inches. So in order to maintain consistency and make sure that we're doing as good a job as possible at going through this process, we need to make sure that this angle here is perpendicular, right? So now, once again, right, just kind of taking that mirror or that protractor, right, lining it up as good as possible, right, making sure that that 90-degree mark has that object right in the middle of it. I'll just make a little dot here. And now what I can do is I can measure the distance from that object to the mirror itself. So right where my point is, right, I can see that here it is 5.9 centimeters to the mirror. Okay, so this distance here is going to be 5.9 centimeters. So understanding how our mirrors work, if I look just beyond that into the mirror itself, I'll just extend this perpendicular line right into the mirror. I will be able to measure along that line 5.9 centimeters, and that will give me where my object is located, right? So it'll be right here at 5.9 centimeters. So at this point in time, I have located where the object is going to be in that mirror, right? Now, when we look at a mirror itself, any object that is on this side of the mirror is going to be called a real image. Anything that we are looking at that appears to be beyond or behind the mirror, we know that when we look at a mirror, the object is not actually becoming behind that mirror. However, it appears to be. So this here is what we call a virtual image. So anything that is being shown in a plane mirror is going to be a virtual image. It is never going to appear that that image is on the same side of the mirror as the object. It is always going to be what we call our virtual image. And again, it is going to be the exact same distance from the mirror as our object is in real life. So that would also be 5.9 centimeters. So now you might be asking, well, how are we going to get to the point where we get our angle of incidence and angle of reflection? Now, when we as individuals are looking at a mirror, very rarely are we going to be looking from right behind the object. So let's say that in this scenario here, the eye is right here. So this is going to be where we are viewing this object from. Now, when we are viewing that object, right, we need to see really what are we looking at. So what you are going to do now is you are going to draw a line from the eye itself, right? We'll just kind of go from this point in the middle of the eye all the way to the object itself. Now, when we are drawing lines behind the mirror on the virtual side of the mirror, we are going to use dotted lines. So I'm just going to draw a dotted line on this side of the mirror, and anything on the front side of the mirror is going to be a solid line. So at this point in time, this here will be our angle of reflection. So we're actually doing it in reverse of what we saw in our first example. So I'm just going to draw an arrow here, showing that that light is coming from the object, bouncing off of the mirror and back into the eye, right? Once I do that, I can actually just kind of skip ahead, and I can also draw my angle of incidence, which will be traveling from the point where my reflected ray is contacting the mirror and going back to the object itself. Now that I have those two things, I can label them if I'd like, right? So this is my reflected ray, and this here is my incident ray. But when we are completing these examples, we also want to make sure that we are including our normal, our angle of incidence, and our angle of reflection. So the next step here is going to be determining where our normal is. So again, just like I showed in our previous example, you are going to take your protractor, you're going to take the point here, and you're going to put it at the location where your incident ray and your reflected ray are contacting the surface of that mirror. And you're going to try and make sure that your 0 degree line is lining up perfectly with that mirror itself to try and get as accurate as possible, 90 degrees coming off of that mirror. So I'm just going to make my little dot at 90 degrees again. I can remove my protractor and I can connect those two lines using my ruler. And now a big thing here, make sure that you are using rulers just to make sure that everything is accurate. Oftentimes your angles are not going to work out very well if you are just trying to freehand this. So we are assuming that as best as possible, this here again is perpendicular or 90 degrees to the mirror. All right, now that I have that normal, okay, again, this is my normal, I can now use that normal in order to determine what my angle of incidence is and what my angle of reflection is. So again, I'll start off with the angle of incidence. I'm going to take my protractor, again, taking my point, putting it at the location where the mirror is going to intersect with the normal, the incident ray, and the reflected ray. So I'll put this upside down. I'm taking that there. I will put it at that location. Again, making sure that my 0 degree line is straight along my normal. I'm going to look back here and I will see that this is almost exactly 30 degrees. Okay, so looking at that, I can look here. This would be 30 degrees. And this here again is my angle of incidence. Now, looking on the opposite side, I know that the angle of reflection should be somewhere around 30 degrees as well. However, it is always good to double check with your protractor. Looking here, I can see that that line is going to pass almost directly through that 30 degree line as well. So I know that this here, my reflected ray, is also 30 degrees off of the normal. So that would be my angle of reflection. So really, when we are completing these types of questions, there are a few things that we are looking for, right? This here, right? Understanding that this is a virtual image. drawing out my incident ray and my reflected ray. So I'm just going to write these down here kind of in a little checklist. Incident ray, reflected ray. Then we also want to make sure that we include our angle of incidence. And my angle of reflection. Okay. And that is essentially how we create a ray diagram for a simple point object in a plane mirror. However, it's not always going to be this simple, right? There are going to be some situations where we have some objects that aren't as easy as this one here with one singular point. So our next sample that we have here is an object that now has 2 points. Right? So again, the process is not going to change here whatsoever, right? My first step is still going to be to determine what the distance is from the object to the mirror. And again, to maintain consistency, we want to make sure that we are using our protractor to try and find the shortest pathway to that from the object to the mirror, which is going to be completely perpendicular. If you are going at any angle to the mirror, the distance to the mirror is going to be slightly longer than what you had originally predicted. So looking here, again, I'm making my mark at 90 degrees, my mark at 90 degrees over here. And now what I can do is I can use my ruler again to measure from the top point all the way over to the mirror, making sure that it is intersecting both of those points that are 90 degrees or perpendicular, right? And I can see here that it is approximately 7.6 centimeters. So this distance here is 7.6 centimeters, right? Now again, I can continue that line beyond the back of the mirror, making sure that it is intersecting through both of those points, right? Now I can figure out where that top point is going to lie on the back side of the mirror or on the virtual side of the mirror. So again, taking my ruler, putting the 0 centimeter mark right on the mirror itself, I am looking for 7.6 centimeters, which will be right about there, right? And that will represent this top point of my arrow, okay? So my arrow is here. So that is also going to be 7.6 centimeters away from the mirror. So again, those distances are always going to be identical to one another. However, in this situation, this object is not now just one singular point. This object is going to be represented by 2 points. So in order to do this as accurately as possible, we need to make sure that we're doing that exact same process for the second point. So again, I am taking my protractor, right? I'm going to try and find where the closest line to the mirror's surface is, which will be at 90 degrees. Again, I'm taking my mark right there, my mark at 90 degrees, and I will measure that distance from the front surface of the mirror to my object itself. So going from there, making sure that it's going through both of those points, and I am seeing that that is 7.5 centimeters, right? So that is 7.5 centimeters from there to the mirror itself. So it's always good to measure these because originally I would have probably predicted that that arrow had the same distance as the top and the bottom points. However, by measuring it, I realized that this here is actually 7.5 centimeters instead of 7.6. Now, is that going to make much of a difference? Probably not. However, it is good to do that just to be sure that we are doing things as accurately as possible. So again, coming over here, measuring 7.5 centimeters back, making sure that it intersects with that line. Now this here would be where my virtual image is created. So I can connect those 2 points. And that is the exact location where I would be witnessing this object on the reverse side of the mirror. Again, if it's on this side, it is a virtual image. Now, our process, again, afterwards doesn't really change, right? Here, we still need to make sure, as we saw in our previous example, we need to find the incident ray, the reflected ray, the angle of incidence, and the angle of reflection. However, this time we're just doing it twice because they are two individual points. So we are going to start with the top point here. Right, I'm going to do these just in different colors. I'll do my first one in red, and then I will do the second point in green, just so that we're not getting mixed up with one another. So looking here, right, I'm going to take, again, my red pen. I'm going to take that on the top point of my virtual image that I've determined its location of. Again, behind the mirror, we're always going to do dotted lines. And in front of the mirror, we're going to use solid lines. Now again, this here, I'm going to put an arrow on it showing that this is my angle, or sorry, this is my reflected ray. And then we can follow that back to the top point on the object. And this is going to be my incident ray. So again, running from the point where the reflected ray intersects with the mirror, right? This here, I can show with an arrow going towards the mirror, right? This is my incident ray. So now looking at those, right? I'm going to go through, I'm going to use my protractor to determine where my normal will be. So again, my point here, I'm taking that, putting it at the exact point where those two rays are going to intersect with the mirror itself. Right, I am finding 90 degrees from those mirrors, or from that mirror, which is going to be over here. And then I can draw out my normal. So here we have our normal, right? I will see connecting those lines. I have my, my normal, right? We should try and get that. That's actually not very great, right? I should really have had that line raised up just a little bit, but for the purpose of this video, it should be fine. So this here is my normal. Right, now I can go through using my protractor. I'm going to determine my angle of incidence first, which is going to be, right, line that up right along my normal, making sure the point is at the location where everything is intersecting. And I can see that my incident ray is going to be about 28.5 degrees. All right, so this here would be 28.5 degrees. That is my angle of incidence. And then I can measure my angle of reflection, right? Now, with that line being slightly lower than the point where those two intersected, this may be slightly off, right? Hopefully not, but it might be just slightly off of what we saw. And yeah, just like I expected, it's 29 degrees. So just slightly off, right? That's why we want to try and maintain as much accuracy as possible, right? As long as these two are within kind of a degree of one another, not really a big deal, but try and be as accurate as possible, just to maintain consistency. And that there is my angle of reflection. Right, but just for the sake of this, right, that is only one of the points that we have completed. So the other point that we have here, we also have to repeat the same process for. Again, this can seem pretty repetitive, but it is really important that we kind of maintain these steps as we go to make sure that we're being consistent. So again, taking my ruler, right, going from the bottom point now, right there, into the point where we are going to intersect the eye, right? And I'm going to run a perfectly straight line there. Remember, behind the mirror, it is a dotted line. Once again, this is my reflected ray. And then I can move that back to the bottom point on the other side of my actual image. This is going to be, I'm just going to run it right through there. That is my incident ray. that is going into the mirror. All right, again, I'm going to make my normal. We can see how here I'm trying to draw it pretty big for you all to see, but things can get pretty messy in these diagrams pretty quickly. So it's really important that we're making kind of straight lines and trying to be concise as possible to try and eliminate any possible errors that we might come across. Right here, I'm just going to make sure that it's right on that line, right at the point of intersection, and make my point at 90 degrees. Right, I'm going to draw my line back to where those intersect with the mirror itself, which is right. So I can tell here just by drawing this line, that normal was much better, right? More so centered into that. So these really should be the exact same degrees. Taking that, right, putting my protractor back on top here, right, making sure it's nice and easy at that point that intersected, right? I'm going to see that this is approximately 24 degrees, right? So my angle of incidence is 24 degrees. I would expect that the angle of reflection should also be 24 degrees, right? So my angle of reflection is 24 degrees. Okay. There, again, we have done everything that we need to. We have indicated that this is a virtual image. We have indicated the angle of incidence and angle of reflection of both from both points into the eye itself. And this would be a completed problem. So pretty straightforward, pretty similar to our first example that we saw, just adding kind of that extra layer of complexity. So for the point of this video, I'm going to kind of stop it here. I will record one more with a kind of more complex couple of questions. And I'll post that on Google Classroom as well so that you guys have it if you want to kind of push yourself a little bit more on the worksheets that you have to work on today and tomorrow. So if you have any questions, let me know, but hopefully this helps.